Last time, I described the phenomenon of comb filtering, a change in the balance of harmonics and overtones of a complex sound wave due to the phase interference of a short, delayed reflection or a second simultaneous performance of the same musical part, combining with the original, first arriving sound just a little out of time. This only happens when the delayed sound arrives at the listener's ear within a few milliseconds of the original direct sound, soon enough that our hearing systems fuse the two together, perceiving them as one sound with an altered tonality from the phase cancellations and reinforcements of the various harmonics and overtones. If the delayed sound arrives much later than the original, we hear it as a separate, repeated iteration, which we all recognize as an echo. But how much of a delay, how long a delay time are we talking about in each case? Well, if the delayed sounds in this scenario combine with the direct sound with less than around 30 to 50 milliseconds delay, human hearing response merges or fuses the direct and reflected waves into one sound, as I just described. This delay range is called the fusion zone. However, if the delayed reflected sound arrives later than around 30 to 50 milliseconds, depending on the nature and the attack characteristic of the original sound wave, then our hearing systems do perceive them as two separate sounds, one after the other. Initially, the repeat may happen too quickly to be described as an echo. Instead, it's what drummers would call a flam, two notes that sound one after the other very rapidly. Once the delay time reaches about 80 to 100 milliseconds or so, the delayed reflection is clearly perceived as an echo. And this is the echo zone. This hearing response, subconsciously merging the sounds together at short delay times, but perceiving them separately at longer delay times, is a psychoacoustic effect of human hearing, and it's called the Haas Effect, or the precedence effect. The Haas effect also notes that if a sound and its delayed reflection are separated by a delay time within the fusion zone, less than 30 to 50 milliseconds apart, and originate from different locations, like one in the left speaker and one in the right speaker, our hearing will perceive them as one comb-filtered sound, but it will appear to originate from the direction of the first arriving sound. This is also part of the Haas or precedence effect, and it's known as the law of the first wavefront. In this example, the original sound is coming out of just the left speaker, and the delayed one just out of the right, after a delay of only a few milliseconds, well within the fusion zone. As you can hear, there appears to be only one sound, to the left, though its tone is altered when I switch on the delay. If I delay the reflection further, until its arrival time falls outside the fusion zone, within the echo zone, you can hear that it's actually coming out of the right loudspeaker. All of these acoustic phenomena and psychoacoustic hearing responses, phase interference, comb filtering, echoes, the Haas effect, the law of the first wavefront, are the basis of many effects and mixing techniques, and I'll get around to them in the next course on reflection and delay-based effects. But next up, I'm going to shift gears a little bit and talk about the behavior of low-frequency sound waves in a room, and other considerations that we have to deal with when we set up and optimize a room for recording and mixing activity.